Hello everyone. So this is the gas law packet that you're going to be working on for the next couple of weeks. Make sure that you notice that we have units, conversions in here. There's also some nice information to have when it comes to solving these equations. There are one constant that you're going to see in some of these problems, and here are some of the laws that we're going to follow. So first one is Charles' law. It uses volume and temperature. So when it says V1, it means the initial volume and initial temperature. Now if I change something, let's say I change the volume, then I'm going to get a new volume, and that's V2. If I change volume, the temperature would change as well. So I'm going to get a new temperature, T2. So read what you have in your problem. And then you put it in the law to see how you can solve it. So initially I have half a liter at 22 Celsius. Then I put the balloon in the refrigerator that holds 4 Celsius. So I know at a certain amount of time, this balloon is also going to turn to 4 Celsius. It will then get a new volume. I turn the equation around, so I get the unknown, which is volume 2, on one side. I take out Celsius, and I'm left with the answer in liter. So this is the new volume of that balloon after I put it in the refrigerator. The next law is Boyle's law. The initial pressure times the initial volume equals the new pressure and new volume. So again, I just find what I do have of information and put it in, and I have the initial volume, initial pressure. I don't know what pressure I end up with, but I do know the volume I end up with. And so I put X on one side and then solve the equation to find out I'm ending up with 1.75 atmosphere. That's the end pressure. Now check your answer. It says here that I have 5.6 liters and a piston at a pressure of 1.5, and I compress the gas. So if I compress a gas, the pressure should go up. And so we can see it started with 1.5 and ends with 1.75. It checks out. Gay-Lussac's law deals with pressure and temperature. Initial pressure over initial temperature equals the new pressure over the new temperature. And here you're going to see a new unit, PSI. That's also a unit for pressure, usually used like when you're gonna inflate your tires on your car. Again, you fill in the information you have, solve it for X, and I found out here that at 81 degrees Celsius, this can will explode. And just check your answer. Does it seem like a fair temperature? Well, I know that the temperature needs to rise from 27 to something for it to explode, and it is going up. So it checks out. 81 Celsius is pretty high temperature. I don't have any strong beliefs thinking that this math is not correct, because I do think a can explode at 81. So for me, this math checks. We're going now to Avogadro's law. Now, here the maths get much more complicated. I can't just put in volume and moles in here, because I have initial mole, but I don't have initial volume, and I don't have the new volume and new mole, because the problem isn't asking about that. It's asking what is the volume of 7.15 mole of propane. And so it says STP, and that means standard temperature and pressure, and that's 0 Celsius and 1 atmosphere. So I'm going to use this law instead. It has a constant in there, and the constant for when we are dealing with liters and atmosphere, it's in Kelvin. So I have to turn my Celsius to Kelvin. All the units have to match. I fill in, I know the volume. No, sorry, I do not know the volume. I want to find out the volume, but I do know 7.15 moles. I know what R is. It's on the first page. The temperature is 0 Celsius, so that's 273.15 Kelvin. I know the pressure, that's 1 atmosphere. And so I solve it and find out the volume is 160.34 liters. So the next problem also have same kind of problem. You can't solve it without doing a little bit of conversion. And in here it asks about mass, and mass isn't gram or kilograms. Mass is something you weigh. So I'm gonna need the molecular weight and the mole to figure out the mass. And then I can use this law to figure out the mass. So you're gonna see, moving forward, and we are looking at the ideal gas law, which I've been using a lot already. You need to look at the information you have there, and you can't use Celsius and Kelvin and Pascal and atmosphere together. You have to have the same units. So the first thing you should do, turn all those units so they're the same. So we have your Celsius and Kelvin instead, and your kilopascal in atmosphere. And you're going to see that on the first page. So it's essentially just taking the Pascal that I have divided by 101.3. 101.3 Pascal is 1 atmosphere. So I'm going to have the answer here in atmosphere. So that's basically it. You can also try combined gas laws. I am going to talk a little bit more about moles, molar mass in another video. As you can see, I'm going to use that here in this problem. So I'm going to refresh you on molar mass in another video.